So part A asks you to name the following ions. So when we're naming ions, there's different kinds of ions. Some ions are just one element. Some ions have more than one element in them. What's the name for an ion, the general category name for an ion that has more than one element? Starts with a P. Polyatomic. Polyatomic elements have special names. You should work on memorizing them, but for the worksheet, look them up if you need to. So when we see something like this, that's going to have a special name. Ions generally have a single name. There's a couple of them that have the word hydrogen and then the rest of their name, like hydrogen carbonate. But I don't want you to look at this and do something like monohydrogen, monosulfur, tetraoxide. Okay, that's very creative, but this is not creative writing class. This is chemistry, and there is one right answer. Okay. With the monatomic ones, we've got cations and we've got anions. The cations are going to be metals except for this guy. This is a positive ion that is not a metal, but he's polyatomic, and you'll find his name in the table. For the metals, there were two kinds of metals, right? There's metals that need a Roman numeral and metals that don't. The ones that don't are in groups 1, 2, 3, zinc, and silver. If it's not in one of those groups, it needs a Roman numeral. So let's do letter A. This is a monatomic ion, and K is the symbol for which element? Potassium. So we need to find potassium on the periodic table. It's way over on the left side. It's a metal, right? Does it need a Roman numeral? No, it doesn't. And so then the name of the ion is just the name of the element. So this is potassium ion. If you put a 1 in Roman numerals after that, I will mark it wrong. It doesn't need a Roman numeral. If you forget the word ion, I'll overlook it. What's the pattern for these monatomic anions? These are all going to be nonmetals, right? I said the metals are like the men and the nonmetals are like the women. And when they get together, like a guy and a girl get married, then the woman changes her name, right? So these nonmetals are going to change the ending of their name. So we change oxygen to oxide. So this is oxide ion. We don't need anything in the name to specify the charge because we can find the charge from the periodic table. So any questions about that part of the exercise? Yeah, there's a way to do that, but I don't know how to do it. Okay. Bless you. Part B is giving you names and asking for formulas. You find part B? Looking at these names, here's bismuth with the Roman numeral 3. Anytime you see the Roman numeral, that's a metal. And bismuth might be one that you may not remember the symbol for, but it's Bi. And so he's hiding over down here. So how would we write the symbol for bismuth ion? We need the element symbol, right? Is Bi. And what's the charge? It's 3+. The Roman numeral tells us the charge because we can't figure it out from the periodic table. for things like, well, there isn't an example of that. If we had something like sodium ion, we figure out the charge from the periodic table. Group 1 is +1, group 2 is +2, group 3 is +3, zinc is +2, and silver is +1. If it ends in "ide," it's most likely a monatomic nonmetal anion. So telluride, I don't know, that makes me think of skiing in Colorado, right? Because there's a city named Telluride. Not that I've ever been skiing in Colorado, but I know that people do that. So what on earth is this? Well, there is an element named tellurium, who's down here, Te. And that would be considered a nonmetal for the sake of nomenclature because it's actually a semi-metal, but it's on the right side. It's on the nonmetal side of the line, and so we're going to name it like it's a nonmetal. So telluride has the symbol Te. And how do we find the charge of those nonmetal monatomic ions? It's on the periodic table, right? We can take the group number and subtract 8, or we can count backwards from the noble gases. The noble gases are 0, group 7 is -1, group 6 is -2. Telluride ion has a 2- charge. And so even though we've never done anything with telluride ion in class, we can follow the pattern and write the formula for the ion. Some of these, especially if you see 8 or ite, those are going to be polyatomic ions, and you go look them up if you haven't memorized them yet. Any questions about part B? Yes?
So would B be Cr3 plus?
Which one?
The fourth one right there?
Oh, D. Yes, yes it would be. Yes. Roman numerals are only used on metals, and so it always indicates a positive charge, never a negative charge. Question in the back.
How do you know that size starts from 0, -1, -2, and so forth?
Well, it has to do with the valence electrons. And all of these main group elements are going to form ions in a way that they end up with the same number of valence electrons as a noble gas, which is 8. So the elements in group 7 have 7 valence electrons. They need to get one more to have 8 valence electrons. It's especially stable energy-wise. So gaining 1 electron gives them a -1 charge. Tellurium is in group 6A. It has 6 valence electrons. It needs to gain 2 electrons. And we look at the metals like sodium has 1 valence electron. The easiest way for it to get a full valence shell is to lose the one that's on the outside because underneath is a full shell. And so it forms a +1 ion by losing 1 electron.
Does it go negative? How far does it go on each side?
It kind of peters out around group 4. They gave you an example of a C4- ion, but those are pretty unusual. So we'll see 3+ and we'll see 3-, but we rarely see 4+ or 4-. The 4+ would be metals, and that's fine, but in terms of the nonmetals, we rarely see a -4 charge. They just don't form ions very much.
The hydroxide, would it be HO or OH?
It's always written OH-, yeah.
Why is that one a minus?
It's a polyatomic ion. And so that kind of comes down to, at this level, because I said so. Yeah. It's good to want to know why, but sometimes, unfortunately, the explanations are just beyond what we can understand right now.
Does perchlorate, does that have the H, or like HCl? Or
No, these are ions. So perchlorate ion is, if we remember, chlorate being ClO3 with a -1 charge. Perchlorate is hyper. It's got 1 extra oxygen, right?
not an ion?
It's an ion. It still has the same charge, -1. If we put an H on it, then it becomes an acid. And so we're starting out here with just writing formulas for ions and naming ions. So let's see, discard. The next section, part C here, is asking you to write an ionic compound from the cation and anion using the correct subscripts and name the compound. So the first one was done for you, but I'll do the second one. So here we're giving you the name and the formula of each of the ions, the cation and the anion. And so I'm going to look at this rubidium ion, and this has a +1 charge, and cyanide has a -1 charge. And we have to figure out how many of each do we need so that when we put them together, the charges add up to 0. When you have a +1 and a -1, you just need one of each. And so then the formula is just writing those two together. The metal always comes first in the name and in the formula. So it'll be RbCN. That's a capital N. That's nitrogen. So that's the formula. If the charges aren't the same, then you may have to do the crisscross thing to figure out how many of each. The name then is the name of the metal ion, followed by the name of the anion. So rubidium. We don't have a Roman numeral. Cyanide. Rubidium is in group 1. It doesn't need a Roman numeral. So there's that table. And then part D gives you the name of an ionic compound and asks you for the formula. The table gave us the names and the formulas for the ions and asked us to put them together. So when we're dealing with a name like this, then the first thing we have to do is identify what are the ion formulas, and we need their charges. So lithium, we find lithium on the periodic table. Lithium has the symbol Li. And what charge does a lithium ion have? It's +1 because it's in group 1. And chloride is the element chlorine, so this is Cl. And we use the periodic table to find the charge of that ion. The noble gases are 0. This is in column 7. It's 1 negative. It's over to the left 1, so it's a -1 charge. Then we look at the charges, +1, -1. All we have to do is put them together. And then over here on the line, we write our answer, which is LiCl, just one of each. Remember, if you have more than one of a polyatomic ion, then you need to put parentheses around it and put how many of those are on the outside. Part E is molecular compounds. They're giving you formulas or names and asking you to write the other. Molecular compounds, all of these are binary, 2 elements, and this is where you can use the prefixes. Di, tri, tetra, etc. Remember, if the first element only has 1, we usually leave that off. So here for carbon, we're just going to say carbon. We're not going to say monocarbon. We'll just say carbon. And then to indicate how many of the second element, there's 2, we're going to use the prefix di. And it's 2 oxygens. We take oxygen's name and change the ending to oxide, and this is dioxide. Carbon dioxide. This one, dinitrogen tetrafluoride. There's nitrogen and fluorine, and the prefixes tell us how many. Di means 2, so 2 nitrogens. It's going to be N2. Tetrafluoride. Fluoride is F. It's not FL. There's no FL on the periodic table. Always get somebody doing that. And tetra means 4. So N2F4. And sometimes these formulas or names look strange to us. That doesn't mean they're wrong. You know, maybe you want to question it, but it doesn't automatically mean it's wrong. Oh yeah, this is a fun one. Fill the formulas in each appropriate space. So here we're giving you a whole mess of ions and asking you to combine them and just writing formulas. So it might be helpful, and there's room in the little blanks, to write the formula up here. So cyanide is Cn minus. And you might want to go through the whole row there and write down what the formula is with its charge. An ion has a charge. A compound doesn't have a charge. And then lithium. Well, actually, I'm not going to do lithium. I'm going to do magnesium. So magnesium is Mg. And we know its charge from the periodic table. That's why it doesn't have a Roman numeral here. So it's 2+. So then where the cyanide column, that's not the cyanide column, where the cyanide column overlaps with the magnesium column, I'm going to look at these 2 ions and figure out how to put them together. One has a +2 charge, one has a -1 charge. I can't just shove them together. Their charges don't add up to 0. So we can do the crisscross thing. And we can take the 2 for magnesium and make that the subscript for the cyanide. And so we'll end up with MgCN in parentheses with a 2 on the outside. This is a polyatomic ion. It's got 2 different elements in it. When I have 2 of them, then I need to have parentheses around them. Otherwise it's going to look like 1 carbon and 2 nitrogens, and that would be something else. So you'll get a whole bunch of practice with that one. Table G is with acids and bases. And we didn't really talk about bases in lecture. Bases are metal hydroxides. So if you see something here that doesn't start with an H or that doesn't have acid at the end of its name, you just name it as an ionic compound, and that'll be fine. And then we've got the acids. Acids start with H. There are different kinds of acids. Let's see. Silly thing. This acid name, carbonic acid, does not start with the prefix hydro. This one does. There are acids that contain oxygen and acids that do not. So if it does not start with a hydro, it contains oxygen, and the name is based on the oxyanion. So that was where we had the silly sentence, Rick ate him before he could bite us. So carbonic, it doesn't have hydro in the front. That tells us this is based on an oxyanion, CO something. We change ic to ate. This acid has carbonate ion in it. And so then we need to know what carbonate ion is. Carbonate ion is CO3, 2-. To make the acid, I'm just going to look at the charge, and that's going to tell me how many hydrogens I need. So carbonic acid is H2, not S, CO3. This acid, H2SO3, we look at that, it's got oxygen in it. So we're going to cover up the hydrogen and look at what's left and figure out what's the name of that oxyanion. It's got a charge on it, but we don't have to worry about that. What's the oxyanion SO3 something? That's sulfite. So sulfite, we change ite to us. Rick ate him before he could bite us. Ite and us go together. So this is sulfurous acid. If it starts with hydro, it does not have any oxygen. So hydrobromic acid is just hydrogen and bromine. And you use the ion charge for bromide to figure out how many hydrogens. Here down at the end, if I'd been thinking, I would have moved this to the beginning, but here it is. You don't need to write formulas or names for these. You just need to identify what kind of compounds are they. Remember, ionic compounds have metals in them. Ionic compounds contain metals. The one exception that we'll come across is if it starts with ammonium, NH4+. That's the only positive cation we're going to deal with in this class. A molecular compound has two nonmetals. Two nonmetals. And then there are binary acids and oxyacids. Oxyacids have hydrogen in them. I'm sorry, all acids have hydrogen. We tell it's an acid because it starts with H. Oxyacids have oxygen also. The binary acids do not have oxygen. And that goes on for a while there. This table, is this the last one yet? No, it isn't. This is a stinking long sheet. As you're doing it, if especially on these big tables, if you feel like, okay, I think I kind of have a hang for this type of exercise, you might want to go on and do at least part of each section instead of just getting the first three things done and then having the last ones not done at all. Because that way you can kind of get your feet wet on all of them. You may need to finish this at home. This table is giving you formulas and names, but now we've got molecular compounds, ionic compounds, and acids all mixed up together. And so it's really helpful to identify first what kind of a compound am I dealing with. If you're looking at a formula, look at the first element. Is P, phosphorus, a metal? No. So not a metal, and I've got one other nonmetal, two nonmetals. This is a molecular compound. So then when I do the naming, I can use the prefixes di and tri. This guy, we look at the first element, sodium. Is sodium a metal? Yes, it is. This is an ionic compound. I'm going to figure out the name of the cation and the name of the anion. You can only break it into two pieces. Yes, there's a whole bunch of atoms in there, but you can only make two ions. Usually it's the first element and everything else. If you're looking at names, check the element that's first. If that's a metal, this is an ionic compound. Acids are easy. They have the word acid in their name. If you see prefixes like di or tri, that's probably a molecular compound. If you see Roman numerals, like this one, Roman numeral. That's a big giveaway. This is an ionic compound. Acid formulas start with H. And then you're going to look and see, is there oxygen? This one has no oxygen. HI is going to be hydro. We changed the name iodine to iodic, hydroiodic acid. And then this is always fun. Here are formulas with incorrect names. And you need to fix it. So this is where you get to play teacher. You pretend that your student wrote these answers and you're grading their worksheet, and you need to write the correct answer for those. Here at the end is a helpful table. It's hard to look at it sideways here, but a helpful table with polyatomic ions. So you may want to refer to that. And up at the top is, this is showing the order of listing nonmetal elements in a chemical formula. You may or may not need to refer to that, but there it is.